Welcome to another session. This is lesson 2 polynomial. We have been solving exercise 2.2. This is the second problem from exercise 2.2. Find a quadratic polynomial each with the given numbers as the sum and the product of its zeros respectively. So far we have solved some problems where we are finding out the sum and the zeros of that polynomial. There the polynomial will be given. We are asked to find out sum and zeros of the polynomial, right? But here it is in reverse order. The sum and the the sum and the product of the zeros are given. We are going to find the polynomial p of x. Let's do this. I take the first problem. So what is given? Alpha plus beta, which are sum of the zeros and the product of zeros, alpha beta, both are given. So as per the order, sum is the first number, right? So 1 by 4, and product is the second number, minus 1. Okay. To start the solution, let ax square plus bx plus c is a polynomial. Okay. In the next step, so what is the sum of zeros? Alpha plus beta equals minus b by a. This is the formula, right? The standard formula of for sum of zeros. So we substitute the value of x plus alpha plus beta here, which is 1 by 4 equals minus b by a. Next, the product of zeros, which is alpha beta equals c by a. So I'm going to substitute the alpha beta value minus 1, which is equals c by a. Let us assume this is the first equation, this is second equation. So look at the first equations. We can derive the value a and b from this equation itself, which is a equals 4, and so minus b equals 1, so b equals minus 1. I hope you understand till here. The only value c we need to find. For that I take the equation 2, I substitute the value of a, and we able to find the value for c. I rewritten the second equation. I substitute the value for a, which is 4. By cross multiplications I found out the value c, which is minus 4. Now we all know that the value for a, b and c. Let's substitute in the standard format of the quadratic polynomial, which is ax square plus bx square plus c, bx plus c, which gives me the polynomial p of x equals 4x square minus x minus 4. Let's do the second problem, root 2 comma minus 1 by 3, root 2 comma 1 by 3. I return the given data. To solution, let ax square plus bx of x square plus c be a polynomial. The next step, I write sum of zeros, alpha plus beta equals minus b by a. I substitute the value for alpha plus beta, which given root 2, and let assume this as a equation 1. Next, the product of these zeros, alpha beta equals 1 by 3. No, c by a, right? Okay. For alpha beta, 1 by 3 equals c by a. I assume this is as a second equation. In the previous problem, what we did, like we did in the previous problem, we able to find the a value and the b value from the first equation itself. I write it down the value, a equals 1 and b equals minus root 2. But if you do it this way, this is totally wrong. Instead, I am going to write the a and c value from the second equations. Okay? Because this is where we have the both numerator and denominator. So the value for C is 1 and the value for A equals 3. This way. Next step, I substitute the value of A into equation 1 to get B. Root 2 minus root 2 equals minus B by, for A I write 3, I cross multiply, so minus B which is equals 3 root 2, for B equals minus 3 root 2. This is the proper way to find A, B and C. So let's substitute in the standard format ax square plus bx plus c. So then we get, so this is our polynomial after substituting a, b and c value. Let's do the third problem, which is 0 comma root 5. So I write the given data, alpha plus beta equals 0, alpha beta, the product of zeros equals root 5. To find the solution, initially we assume the standard format of the polynomial. I return the sum and the product of the values like we did in the previous problems. So here take the second equation. We are able to rewrite this root 5 by 1 equals c by a, which is c equals root 5 and a equals 1. I put the value for 1 for a in the first equations, so I get 0 for b. Then the polynomial is p of x equals, which is a x square plus, for a I write 1, no need to write 1, so I simply write x square alone. Since b equals 0, no need to write the b term, so directly I write this constant value root 5. This is what our polynomial is. Let's do the other problems 4, 5 and 6, which are very easy, which are following the same technique. So I return the given data, alpha plus beta equals 1, alpha beta equals 1. And as usually we do what we do initially, we assume ax square plus bx plus c be the polynomial. You can take any one equation because all are 1, which are, so it will be very easy. So which is a equals 1, I take second equations, and c equals 1, and directly we are able to find from the first equation itself the b value. No need to substitute any value right here, so which is b equals minus 1. So which are very easy. Then again the polynomial, which are the standard format, I apply the a, b, c value, which gives me x square plus not plus minus x plus 1. So this is our needed p of x. This is the fifth problem, which are very easy again. So I write everything, the substitution and all, I written everything due to the time constraint. Okay, the only thing is remaining is the value, finding the value a, b and c. So here also you don't need any substitution, so directly we are able to write the values, which are a equals 4, yeah, two sides it's 4, right? So directly we can write 4 here. For b, for minus b equals minus 1, for b equals plus 1, for c, yes, here c equals 1. Done. So our p of x is 4x square plus x plus c. The final one is 4 comma 1, which also very easy. You can try this out on your own. You can pause the video and try it on your own, then come back to check the answer. So here is our answer for alpha plus beta 4. Yes, I returned the given values, and as usually let ax square plus bx plus c be the polynomial. For alpha plus beta equals minus b by a, I write alpha plus beta 4 equals minus b by a. I assume this is as equation 1. For alpha beta equals c by a, I write alpha beta 1 c by a. I assume this is as 2, which gives me the answer a equals 1. So both equation a equals 1 and c equals 1 and b equals minus 4. So our p of x is, after substitution of a, b and value c, x square minus 4x plus 1. So we finished exercise 2.2. I will come up with a different topic in the next video. Thank you.